There's a local radio station where I live that had a commercial that said, "Call 602-222-FOAM." And my wife and I found that so endearing that it naturally follows I'm going to make a video about foam today. Whether for acoustic or packaging, I think we've all seen this kind of wavy foam before, and it's kind of fun to use equations and equation sketches in Alibre to make this. Let's get started. So here we are in the new part environment, and one thing when we use these equations, I highly recommend that we go to Properties and change the dimensions of this part to millimeters if you're not in there. So now that we're in millimeters, let's go to Script and launch our Alibre script console. I'll head to Examples, Mathematical, and stand on Equation Sketcher, and then I'll run to the top and run this Python script. So I'm going to start at 0, 0. We're going to say equation is sine of x because we have a sinusoidal kind of shape to foam, and what better thing to use than sine? I'll stand on my plane and select the xy, and then we'll end at how about 100, and we'll put 1,000 points in between. So that has made our sinusoidal pattern. Now, we've got our xy plane here. I want to know how far out should I make my next equation-driven function, which will be a cosine and off by about 90 degrees. So we'll say that one period or one complete cycle of the sine function is 2 pi. Right, that kind of takes us back to trig class, and we want to go half that to pi. So I'll go with, I'll go back to my model. So we're going to create a new parameter, and I'm going to call it distance. My equation will be simply pi. I'll apply that, and then I'll check this as a favorite so I don't lose track of it. And from here, I can now create a plane that is offset by pi. And instead of typing in pi, I'll click on this f of x. I can see my checked distance right here. So we're going to say OK. Close that. All right, so let's go to Script, launch again, and then I'll go to Mathematical and stand on Equation Sketcher. We'll run that script. So we're going to say 0, 0. We're going to say equation is cosine of x, but we want to move the function just a little bit so it is exact opposite of sine. So we're going to say plus pi divided by 2. 0, 100, 1000, and OK. Oh, we have to select our plane. So we'll select plane 1 that we've just created. And there is our sketch, and we've done it correctly because you can tell these are mirror images of each other. So I can probably not launch my Python console anymore because I think we have everything we need. I'm going to make a quick edit to my initial function. As you can tell, I can move this around if I choose to mess with it. So I'll lock it down by making it coincident. And then I'll give the endpoint a vertical dimension simply to lock down this sketch, and then I'll make a line. Right, we'll go down, over, and up. Make sure that this is horizontal. Yep, it already is. And then we'll make sure that this is vertical. And give this a distance, maybe 3 millimeters. Deactivate. Generates the last feature, and we'll edit this same sketch. This time, I have the luxury of importing this with maintained association. Line, line, and we should be good. We can still move the end of the sketch around a little bit, but I can always say coincident, and then we're good. All right, perfect. Let's make a loft. And we'll go from here to here. We're going to specify a tangent and tangent. And I'm going to change this to 0.05. 0.05. So that's starting to look like foam. Foam. We'll mirror this feature across this plane. So now that we have a high point here that ends in a high point here, and all these high points correspond to the high points, we can just linear pattern it. And we can choose a linear path, right? That's going to be a straight edge there. For spacing, this is where our distance comes in, right? We can say distance. And we want to multiply that by 2. Since we've mirrored the part, we're going to be double the thickness. So we'll let distance come in, and then we'll say distance times 2. And then I'll give that something like 8 and say OK. There's our pattern, so we'll say OK. And there we have foam. So kind of fun to be able to run an exercise through sketching equations to come up with something like this. And another cool thing is I can open up my equation editor, right? I've got my checked one right here, so I can sort by my favorites. And instead of pi, what if I want to elongate it? Well, because I did my equations right, I can do something like pi times 2 and make it twice as long in one direction than in the other direction. So equations are kind of fun for reconfiguring parts like that. Now we're pretty long on this side and still pretty short on this side. You might argue that scale would do the same thing, but it's fun to be able to reconfigure parts just the way you want using equations. Hope this video was helpful. If it was, please subscribe to the Alibre channel. Thank you for watching and see you in the next one.